on this note page, make sure when you say the x, you got x equals the 1, 2, 3, and then dot, 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 dot. Okay, that means out to 25. All right, and then x squared. You want 1, 4, 9. I want you to actually fill in the dots. So like 16, 25, 36. Okay, so I want all the x squared values from 0 or from 1 to 25, and all x cubes. Let's have x cubed only go out to, we'll go up to like, we'll do the first 5 x cubes. Actually, first 6. Let's go out first 6.
That's an awkward number.
Yeah, it is. Okay, so copy that on the side of your assignment today. Yes?
Is the summarized theorem 10.7, is that the box thing right next to it?
That is the box thing right next to it. So the summary of 10.7 you don't actually have to get a book for. That's kind of right here.
Okay.
We referred to it yesterday. So I'll give you a minute to work on that and then take out yesterday. Okay, can I have your attention back up here? Here we go. Let's get this filled out. So x squared is?
1.
For 2?
4. 9.
9.
16.
5 squared?
25.
6.
36.
7.
49.
8 squared?
64.
9 squared?
81.
10.
100.
11.
1.1.
12.
1.4.
13.
1.69.
14.
196.
15.
55.
16.
256.
Okay, from there you should have memorized.
What?
You should, whoops, this got kind of offline a bit there. Hey, but these should be memorized. Okay? You should memorize up to 16. You should also memorize 20 and 25. Okay?
406.
Now, if you really got this, you'll be able to memorize a little further here. All right? So, we're only set up to 6 on cubed. All right. 17.
289.
289. 18.
324.
I hope your table looks better than mine. That's so bad. 324. 19.
361.
361. 20.
400.
And 25.
625.
625. Now 25, 625, it's usually an easy one. Remember your road markers, you got 400, or 20 is 2 times 2 and add 2 zeros. That's 400. 30 would be 900. 40 would be just 4 squared with your zeros added on. 1600. 50 would be, come on, what's 5 times 5? 2500, right? You guys remember, look, when you're doing, say, 50 squared, that's just 5 times 5. It's 50 times 50. Okay? 5 times 5 is 25, and you add your 2 zeros on. 2500. Okay? All right, hey, cubed. 1 cubed is?
1.
2 cubed?
8.
3 cubed?
27.
4 cubed?
64.
5 cubed?
125.
6 cubed?
216.
256?
216.
Oh, 216.
1000.
Very good. Hey, so don't get 256 and 216 confused. Okay, on those. You should have through 6 memorized. Okay? Now you can keep going, but through 6 memorized there. Okay. Any questions? All right, so today theorem 10.7 says, remember yesterday we dealt with A is to B, so the area ratios where A squared is to B squared, so this was perimeter or similarity. This one's area, and then for volume, we're in cubic units. So A cubed is to B cubed. Okay, so similarity ratio and perimeter ratio, area ratio, and volume ratio. All right, so this is going to help us. If we're given the similarity ratio, we should be able to find the volume ratio. If we're given the volume ratio, we should be able to find the similarity ratio. All right? Okay. So we should have that into our notes. Let's go ahead and score yesterday's assignment, then we'll dive into today's stuff. So take that out, please. All right, I now want you to take a look at the mixed side of your assignment. We're going to work through some of these problems together. I like this table. So just so that we're clear on how to deal with these, it's very similar to yesterday when we're dealing similar and similar. That's kind of fun. Okay, we're dealing with similarity ratio. You're going 1:3 on similarity ratio. If we're going to area ratio, everyone write down the area ratio for that. Okay, so to go from here to here, we square it, right? So I'm just going to show that by showing x squared. That makes this 1:9. 9. Okay, to go from here to here, what do we do?
Cube it.
You cube it. Okay, and x cubed. So Nick, what do I get here?
1 to 27.
Good. 1 and 3 cubed is 27. All right. So right now, I want everyone to do as much of this as you can. Yeah, some of these you're going to have to go backwards. So. Okay, I want to get some of you up there to fill in those. You can only do one set. Okay? Yeah. You can only do one spot.
Should be 25, right? 25 and 4, right? Yeah.
Make sure yours
Wait,
matches there.
one row or one?
One row.
No, just one
How
little
could
spot.
or be right if
In the big C.
I'm really confused.
Crap.
It makes sense to me.
That's right, right?
That it would be
No, it's
27
so
to 27. That can't be right. Don't worry, Nicholas. 256 does not go to but 256. What if you just multiply 27 by 3? 13? No.
16. It's a perfect square, 16. If it's a perfect square, right? Oh, wait.
500 doesn't go to 16.
No, 10 over 5.
What?
But actually, no.
No, because this,
I know.
that doesn't make any sense.
We're stuck now?
What? Oh,
Go
so
on.
you're finished.
I did one.
I can do that. Did you guys get 125 to 260?
You can only do one.
There's 205 yet.
Nice little.
Yeah, I got 1319. 1319.
Wait. What'd you get for the first one?
Yeah, it does.
Because it reduces to 1 to 27. What'd you get for the first one?
2 to 3, but we're not entirely sure that's right. Well, I think the 2 to 3 part's right. I don't think this part's right.
Actually, no, that could be right because if you reduce to this, then that would be 3.
2 to 3 is right.
Yeah, so then you have to square that. That's 8 to 27, so it has to be right.
Yeah, it just doesn't make sense.
Yeah, no, it does. Because if you reduce, because 12 to 27 is an X perfect. Must reduce.
No one else?
More. Okay, I'm gonna go try this.
I don't know how to.
It's okay to make a mistake. It gives me a chance to teach, man.
Cubed of 3. You guys got 1 to 3, right?
No.
For 5?
Yeah.
Because like,
But 1 cube isn't.
no, but it's not reduced yet.
Yeah.
You have to reduce it. When you reduce it, then
And it goes to 1 to 27. So it makes perfect.
Because yeah, 81 divided by 3 is 27. So then you divide each side by 3, so then it's 1 to 27. Then they all line up perfectly.
Because 1 times 1 times 1 is 1.
Yeah. So 1. multiply.
Because it says it's proportions.
Give it up, huh?
No, we just can't answer more.
We can't.
Well, can't we get? No one can get either 4 or 5. The other part of 4 or 5.
We already went.
We don't think we're right.
There are a lot of people.
Allie. Yeah, Allie. Look, you do the squares. 5.
All right, you can't spend any more time waiting. All right, well, let's check the ones we have. Thank you for coming up if you did. So 5 to go from here to here, we square. So 25 to 4, that's good. 5 cubed is 125, 2 cubed is 8, that's good. Okay, well, we start here, so to go backwards, we have to square root, right? So 25, the root of 25 is 5, root of 36 is 6, good. And then to go from here to here, we have to cube it. Now, we cannot go straight from here to here, right? You can't do that. All right, you actually have to go home. This is your home. You have to go home first and then go back. Okay? So, 5 cubed, good. 6 cubed. So we always have to go back to our home base before we go to volume. You can't start at 1. You can't start here and just jump to here by squaring that. You've got to square this. So take the root of this. Is that 2?
No. You have to reduce it.
Oh, reduce it. Very good. Who did 2 to 3?
Jordan.
Okay. So Alyssa, what do you get when you reduce it?
Emily.
I did it.
Emily did it.
4 9s? You got 4 9? Oh, you got 4 9? Okay. You pull 3 out of each of those, and the root of 4 is 2. The root of 3 is, or 9 is 3. Okay? And then we go from here to here. 2 cubed is
Oh, wait, my one. 27.
8. And 3 cubed is 27. Okay, so square root this. So we go back, and then we cube. Everyone with me? Always go back to home. This is home. Got to get back to similarity ratio first. Okay, so here we have 1 to 3. So I'm assuming whoever did this, who did this one? Good. So yeah, took the cubed root?
No, I reduced it.
Oh, reduce it first. Okay.
So it's 1 to 27.
Good. 1 to 27. Always reduce the fraction if you can. So remember, 3/81 is 3 to 81 is same as 3/81, which reduces to 127. All right, and then we can take the cubed root. So we go back this way. So take the cubed root. Oh, you have those perfect cubes we came up with to begin with. The root of 1, or the cubed root of 1 is 1, and the cubed root of 27 is 3. And then we go from here to here. So we've got to square it. We can't go directly from here to here. That's not okay. All right, so 1 and what's this? 9. All right, knowing that now, knowing that you should always reduce first and always go back home first, the similarity ratio, I want everyone to finish number 6.
I'm trying. I don't figure it out. Goodbye.
Don't complain.
You don't have to write them, right?
Yeah, I know, but I want to have them.
It's 125 cc.
Don't ruin the movie forever.
She always does that to me.
What?
All right, so 500, 256. 500 over 256 reduces to?
125.
Good. A lot of you will you'll start just cutting in half. If you did that, you get 250 over 128, and then cut it in half again, 125 over 64. Yeah. And so you're looking for perfect cubes, right? 125 is a perfect cube. 64 is a perfect cube. The cubed root of 125 is 5. That did not help at all with that focus. My goodness. Whoa. All right, that's not helpful. Let's try that again. Hey, oh, that's a little better. Well, anyway, Sorry, the focus isn't working as well as we wanted to. So, and I know I can't get that thing on. All right, well, you're going to have to deal with that. So, the root of 125 is, the cubed root is 5. All right, that gives you 5. The cubed root of 64 is 4. 4, yep. And now we square it. And that gives us 25 to 16. All right. Okay, everyone rate themselves 1 to 5. Okay, very good. Any questions? All right, I want to try this one right here, number 7. Be helpful if that little thing wasn't on the screen there. Let's see.
Menu okay.
I did. Nothing will happen. It's frozen.
Oh no.
Yeah, I know. There.
Uh-oh. Cheerios.
It's all right.
Okay,
Yeah.
so if you go back,
Thanks.
square root 4.
You can get rid of the pie.
I know.
All right.
Bye.
JJ, that's impressive, dude. Nice. All right, there you go. Give that one a go.
Oh, then,
Yeah, 128 over 27.
no.
Lily?
Okay, I'm assuming everyone's read it now. So the areas of two similar solids at 16 pi and 9 pi. The volume of the larger is 128 pi. Find the volume of the smaller. So we're trying to get to here. Right? We need to find that ratio so we can use it. Now, finding the ratio doesn't tell us the answer. We need to find the volume of the smaller. What do they give you? Do they give you similarity? Do they give you area ratio? Or do they give you the volume ratio?
Area.
They give you area. Now, how do you know that these are area?
70 squared.
It says lateral area.
Good. It says lateral area and it says square units, right? So we can make up a ratio of area, 16 pi over 9 pi, or 9 pi over 16. Okay? And from there, let's cancel the pi's. I know. Let's take the square root and then cube it. Give that a go. Find those ratios.
Yeah. Oh, yeah, I just have the other way around.
I got 18.
Okay, square root. Bring it back to the similarity ratio. What do we get?
Over 9.
4 over 3. Cube it. What do we get?
27 over 64.
27.
Or 64 over 27. Depends on
Yeah.
Oopsies.
64 over 27.
Lo siento.
Okay. 64 over 27 there. Is that our answer?
No.
Oh,
You can simplify it. See?
good. Someone that hasn't volunteered today, what do I do next? Hannah, what do you think?
You set it equal to 128 over x.
Good. We're going to take our similarity ratio and we're going to use that 128 pi. Right? Is that the larger or the smaller?
Larger.
Yeah, it's the larger. So does it go on top or bottom? Goes on top with the larger. So 128 pi over x. And now we can solve.
54.
Right? Cross multiply. 64x is equal to, I have no idea what that is.
Oh my god.
It's like a big number.
Divided by 50.
What's that? 200,
54 pi.
2,456 pi.
Okay.
Can you just recognize that you double it? Wouldn't that be easier?
That you,
That
you just double it.
Wait,
The relationship.
what?
Like 64.
Oh, yeah, I see what you're
You
saying.
just
Yeah.
double it.
Yeah. Is that?
Wait.
No, what? The answer's 54.
2,456, and then divide by 64.
Which is 54 pi.
Good. So x equals 54
Good job.
pi.
Oh,
Hey,
you have to put
you guys, Maddie was saying that, look, from 64 to 128, you just double. So 27 to x, you could just double as well. That could give you 54. Good. Yeah, that's proportional. That's a lot easier, actually. Cubic centimeters. All right. Hey, I want you guys to try number, I'll be walking around. I want you to try number 8. So if you had questions on 7, make sure you ask me while I'm walking around here, please. Hey guys, I've got to come back to this, and some of you just picked this up probably on your own. What's wrong with this? This number.
It's pi.
Why is there pi?
Okay, pause. How did I get this number? Yeah, I go 27 times 128. How many have actually done that at your desk?
I did.
Okay, what's wrong with this number?
That's 3,456.
Yeah, it's 3,000, right? Hey, that's a major problem. If you're following along, you should have picked up on that, man. Now, I'm not multiplying this out. I'm going based on what you guys say. And if I have 30 of you saying, yeah, 2,456, that, okay, I had one person in class actually point out to me that that's not working out. All right, this is 3,000, right? Otherwise, it does not give you 54. All right? Hey, we can't just be kind of randomly going here. So, everyone, right now, everyone on your paper, you should be getting whatever you need here set. And you're doing it. You're not waiting for me to do it. Okay? I'm going to call on random people here in a minute and get the answers, so be ready. Okay, here we go. Ryan, what do you got for... What do you got here? What did you use first? Okay, so you're dealing with this ratio. Is that right? Okay, the cubic ratio. All right, we don't have to put the cubes here, right? That's just our label. That's telling us we're dealing with cubic. Okay, and so what does it reduce to? 8 over 27. So not 8 cubed, just 8, right? No cubes. Okay, the centimeters are cubed here. Okay, our label's cubed. Bless you. Hey guys, is everyone clear on that?
Yeah.
Label's cubed, not the number right here. All right, and so we use that. We're trying to find area. Okay, so what do we do next? Let's go with number 5 is Hannah Devine.
You cube it, and you cube 8, and then you get 2, and then you cube 47, and you get 3, so it's 2 over 3.
Okay, so you cube root it, right?
Yeah.
Good, and that gives you a similarity ratio of 2/3. Good. And now what are we doing? Hold on, I'm just going random number table here. Lucy. So Lou, what are you trying to get to?
Well, you're trying to get to there.
Okay, so what do you need to do?
Oh, it's good.
So we're going to square this. Okay? And that is 4/9. Okay, now we have the area ratio. What do we do from there? We've got Amy. What do you got?
You do 4 over 9 equals 40 over x.
Good. 40 over x. Is this the smaller? Yep. Good. Smaller. So make sure we put it in the right spot. Good. Okay, from there we've got Bree. What do we do? Cross multiply. 4x equals, it's 9 times 4. Question?
Well, it's also because 4 times 10 is 40, so you don't do 9 times 10 is 90.
Good. Yeah, you could recognize that as well. Times 10 times 10. Either way, you get x equals 90. Good. And then we should label it square centimeters. Well done. Gracie.
Couldn't you just go from like once you get the simplest ratio on the volume, couldn't you just square that number? Or not, like, square, oh wait, never mind, it wouldn't be.
Yeah, it
Yeah.
doesn't work going just back here. You always have to
Yeah.
go back one. Good questions. Other questions? All right, last one. Number 11. Give it a go. Okay, here we go. So, what do they give us? Alyssa, what do they give us here? Is-
Square centimeters and 10.5.
Wrong problem. We're on 11.
11?
Oh, we're on 11.
Yeah. How about we'll go to go to Jordan here. Jordan, what do they give us?
They give you that there's a hammer-shaped pile of sand and it weighs 250 pounds, and that the similar one, each dimension is 6 times as large. So then, yeah,
So which one of these can we pick out from that?
I would use the third one because it's each dimension, so you would be cubing it because you would have the length and the height.
Or the similarity ratio.
Okay, any other thoughts on it?
Wait, Jordan, what one did you say it was?
She was thinking similar, or the cube,
Volume.
the volume. Thank you. Yeah.
I thought it was the similarity ratio because each dimension, which would be basically like each side, and so then that's a similarity ratio, not the.
Yeah, you guys, that's right. If you're dealing with dimensions and they say in each dimension is 6 times as large, then you're dealing with a side length. So if, say, the side of a triangle, if this was, you're dealing with a triangle and a cone here, okay, and you're saying one side is 1 unit long, what's the other side?
6.
It's 6 units longer, okay? So it's a 1 to 6. Now we are trying to find volume though, because when we're talking about weight, we're talking about the 3-dimension of it, the 3-dimensional aspect of it. So we're dealing with weight in this. Okay, so we're trying to bring this over to here, so we've got to cube it. So that gives us 1 over, not 36, 6 cubed,
216.
216. Good. And then, so that equals, where does the 250 go? Is that the smaller or the larger? It's a smaller. So that's 250 on top. On bottom we have x. So you guys could look at this just like you have been, some of you have been in previous problems. You could say, well, I just multiplied that by 250, so I could just multiply that by 250 and have my answer. Or you can cross multiply and divide. Either way is going to give you your answer. So what's 216 times 250? 54,000. And we're dealing with pounds. Okay. Hey, your assignment is the example side today. Okay? All right.